Hi friends, welcome to my YouTube channel. Hope you all are doing good. So in this video we are going to discuss about the introductory part of soil mechanics. Soil mechanics is the application of laws of mechanics and hydraulics to engineering problems, that is sediments and other unconsolidated accumulations of soil particles produced by the mechanical and chemical disintegration of rocks. Rock is nothing but the origin of soil, which are very big in size, from which the stones and the soil is originated by the chemical and mechanical disintegration. Okay, soil is a pseudo elastic three-phase particulate medium in general, whereas in dry condition it would be a two-phase one. Soil mechanics is the branch of engineering which deals with the action of forces on soil particles with the flow of water. Okay, it is a branch of engineering which deals with the action of force on soil particles with the flow of water. Coming to the scope, where is it is actually used? It is actually applicable in foundations, the retaining structures. Retaining structures in the case of earth retaining structures, okay, and stability of slopes. We also see failure of slopes where the stability is to be maintained. So this is applicable. Underground structures, pavement design and runway, earth dams, miscellaneous problems like soil heaving, soil subsidence, shrinkage, and swelling of soils. So, in all these cases, we have the soil mechanics, which is very applicable to this. So, classification of soils, we have residual soils, also called as sedentary soils, and transported soils. So, transported soils are transported by various factors such as water, wind, gravity, and glaciers, and also combination of this in some cases, and by human interference sometimes. So, they are divided into these types: the alluvial deposits, black cotton soil, laterite soil, desert soil, marine deposits. Okay, this is how it is being transported. This is a geological cycle. Firstly, it is erosion, by which it is getting transported from the origin. In some area, it is getting deposited, where if it is more in quantity, there will be some upheaval. Again, by the transportation, it's getting back to the origin. Okay, this is a geological cycle. When I'm talking about the definition, I told you this is a three-phase soil system. Soil is not a coherent soil material like steel and concrete, but it is a particulate material. That means soil exists in nature, consists of mineral grains and rock fragments, with water and air in the voids. The water and the air in the voids are readily changed by changes in the ambient conditions and location. As the relative proportions of the three phases vary in any soil deposit, it is useful to consider a soil model which will represent these three phases distinctly and properly quantify each phase. So this is the diagrammatic representation. Generally, when we are talking about the three-phase soil system, this is a diagrammatic representation. Okay. See, generally we see the soil mass as in the left figure, but right side when we are classifying that, that is when we are just showing it in different phases, this is it. We are just quantifying that. Okay, this is the solid part, whereas the remaining part is water and air. Okay, this is nothing but the three-phase soil system, where weight of water and weight of solid would give the weight, total weight. Okay, here in the air we are not adding because the weight of air is 0, but in volume we are also considering the air. Okay, V is equals to VA plus VW plus VS, that is voids, the volume. Okay, VB is void volume, V is equals to VV plus VS, that is the volume of void plus volume of solids, whereas the volume of voids is because of the air and water. Okay, next, when we are talking about the two-phase soil system, that is in the case of dry soil, we have only two conditions, that is air and solids. No need to consider water, as in dry soil water is not there. Okay, and whenever we are talking about saturated soils, that is the water is completely on top of that soil, the soil is submerged in that. Okay, so here in this case there is no chance for air to come in, right? So that is just the water and solids in this. That is it for this video, guys. If you like the video, please like, share and comment to the channel, and don't forget to subscribe to my channel. Your subscription would greatly help me. I appreciate you watching this video. Thank you.